So let's break down this entire topic into two parts. The first part will focus on the term vibrations. So we define vibrations as oscillations, or in other words, to and fro motions around an equilibrium point. Let's try to understand this definition by using an analogy. So imagine you went to a gym and you found your friend, who by the way is a gym freak, and it is your first day at the gym, and your friend gives you a challenge that you have to hold your hand like this. So basically this is a shoulder exercise. Now you said, right, well that's easy, I will do it. So you do it like this and you hold it steady and well. So this we can call it as an equilibrium position in this scenario. Now your friend is a little smart. What he does is he gives you a 50-pound dumbbell and he says you have to hold it using the dumbbell now. You give it a try, but because this is your first day, you cannot hold it well and your hand shakes like this. So this you can see is the oscillations around the mean position which you had earlier, and the weight in this case is causing those vibrations. This is not a very perfect analogy in our case, but it will give you some intuition on how things work with vibrations. So remember this and we'll come back to it later in our talk. So now I'll focus on what micro-machining is all about. So micro-machining is made up of two words. Micro, which literally means small, but in our context we can specifically say it's less than a millimeter.
Okay.
And machining is a process where we remove material in order to create shapes and features. One of the most common examples of machining which you might see in your daily life is drilling. So imagine if you want to drill a hole in a wall, then the drill machine is a type of machining process, which is the class of processes which are used to remove material and create shapes.
So it's completely a takeaway, not
Yes.
an addition, but always takeaway.
Yes. So drilling in this case, the shapes and the feature is basically a hole which you are trying to make into the wall. Now in general machining, the material you will process, you can also create, if you want to create specific shapes, for example, the application of these include surgical equipments. If a surgeon needs a forceps to hold very delicate parts, the shape of that forceps should be very accurate in order to have better functionality. So, but what happens is, as you decrease down the scale of those features, you need more and more accuracy in order to get that shape right. And coming back to our original definition of vibrations, if you have vibrations in your system, the shape or the accuracy which you are trying to target you may not be able to achieve it. So overall in this entire study, what we try to do is we try to study how that weight thing is affecting the vibrations of the tool in this case, and what can we do to basically mitigate those issues in order to have better and more accurate shapes in whatever the application which we are targeting.
So are you trying to eliminate the vibrations at all, or simply compensate for them?
So both are possible in the study of vibrations, depending upon the problem which you are targeting. So the two ways to do is, you design your system like this so that you don't have any vibrations. For example, in this case, let's say I replace me with a friend who is strong enough to hold that weight. So I have changed my system itself so that I don't have any vibrations now.
So in the machining, you're simply going to make a stronger original structure? Is that what you're saying?
A stronger tool maybe, if that tool is susceptible to a lot of vibrations. Or I might try to So in machining, the source of vibrations is basically because of the forces which you experience while you are trying to cut the material. So if I make a very stronger tool, then I may be able to cut them easily, like a knife cuts a butter.
Well, maybe you can do that. Maybe summarize all the strategies that are possible here. You can
So
change
the-
materials. You can change
So one of the
systems.
strategies is changing the design of the system itself. The other strategy is, let's say if you have a very strong material which there is no way to have a very strong tool which you can use to cut it, then you need to eliminate the vibrations which are coming from that forcing. So in our previous example which we used, if let's say my hand is not strong enough, then I can use a support here to basically remove the vibration. So these are the two techniques which are used to suppress vibrations